Why, hello there, and thank you for tapping into this episode of Bandwidth Coast to Coast. For this one, as are many that are getting released in this next batch, it was recorded several months ago, nearly 8 months to be exact. A pause I do apologize for. So if you would, forgive a few dated portions of the conversation, such as the Delta variant just getting ramped up in the UK. But other than that bit of ancient history, the remainder of this interview is quite timeless. That is, until we stop using Python as a programming language. For this installment, I asked a previous guest to come back on to talk more about the tools he uses and the ways he uses them. Being a bit of a developer myself, I got my interest piqued last we spoke about how he uses Python, one of the simplest and most ubiquitous programming languages in use today. So I asked him to come back on and talk with me in more detail about the technologies he uses, the various libraries they're in, and how to get someone who's interested in this to get going. There are parts in this episode that get a bit technical, and even with that fair warning, I encourage the less technical of my listeners out there to try to give it a go. If, for nothing else, to understand better the technologies that, like it or not, are quickly becoming commonplace. And to give those a bit of a background, the majority of machine learning and AI programming is done with Python, using some of the very libraries or packages of code that Dr. Balzter is talking about in our chat. Through this step-by-step walkthrough of how Dr. Balzter does his work, you'll get a front row seat to some really amazing things that are being done, some to better understand climate change's effects, and others to see what steps are being taken. Using computer analysis to spot an area that is trending towards drought, leveraging satellite data to help farmers with their crop insurance, or even just to get a look at what the effects climate change is having on our planet. Along with some very illuminating prospects for now and the future on what can be done with the satellite image data. And, well, if this technical portion proves to be maddening, skip past it a bit, because Dr. Balzter brings me out of the technical forest and ends the chat talking about some of the most beautiful areas to view from the heavens above. He even goes into where he enjoys watching the weather, with some great stories along the way. To those of you who may be listening to this that are developers, getting started or currently bashing your head against a wall trying to solve a problem, I have a bit of wisdom to transform to you from Dr. Balzter. It's not how good you are in comparison to others in programming, but how disciplined and diligent you are in chasing your ideas. For even the self-admitted not that great of a programmer can win a Copernicus Award for their code. A truth that extends far beyond just the zeros and ones. Well, with that and no further ado, my interview with Director of the Center for Landscape and Climate Research at the University of Leicester, Dr. Heiko Balzter. As always, I hope you enjoy. Real quick before the episode begins, if you'd like to know about episode drops, check out our episode catalog, find ways to get us on different streaming platforms, or leave us a comment. Please reach out to us at bandwidthpodcast.com. All right, Dr. Balzter, thank you again for your time. I'm really excited to talk with you, as I was just saying. So last time you were on, it was your first time, and I asked you as a question to get started what you like to do, what that makes you happy. So I'm going to switch it a little bit and ask you what you've done this week that made you happy.
This week, I've been out a lot for walks in the neighborhood. There's not much one can do these days outside with all the lockdown restrictions, but I thoroughly enjoy having an early morning walk before I start work and get some fresh air. And often my wife joins me for that, so that's also quite nice.
I like that. Yeah, I make that a ritual every morning, actually. Usually before I have my coffee, but I really enjoy the morning walks and kind of starting your day doing that. So I appreciate that.
Mm-hmm. We had one particular morning that was particularly nice, which was everything was covered in snow and the sun was out and we had a blue sky.
That's gorgeous. I love the look of a fresh coat of snow. It makes
Hmm.
everything seem a little more what would be the right word for this? Like mystical, or like awe-inspiring. It like I'm searching for a word that's similar to like cartoonish. You know what I mean? Where it's like it looks surreal. There you go.
Yeah,
Yeah.
yes.
Uh, it doesn't snow very often by you, does it?
Not very often. This was the first time we had some serious snow this winter.
That's interesting. Are the snow patterns changing? Are you getting more snow or less snow than typically?
It's hard to say. I've only lived in this area for
Mm.
about 13 years or so. So, it's not quite long enough to say what the experience is in relation to the long-term climate. But my feeling is we've not had very much snow in the last couple of years. When we moved here first, there was much more snow in the winter, sometimes extended periods of snow for several months. That hasn't happened so much in the last 5 or 6 years.
Yeah, that's what I was wondering. It's interesting. I'm quite interested in economics, and one of the reasons I'm quite interested in it is because I find it as a bit of a hack to find out a lot of other things. It's
Hmm.
like a shortcut, and one of the ones that was a shortcut was talking about private investment in the wine industry, and how, in particular, there's been a lot of private equity that's going into wines that are made in the UK. Because I suppose like I don't. They were saying like a time period, but historically, British wine, or wine in that region of the islands, was quite bitter, I suppose, because of the climate. But
Hmm.
since it's been changing, it's been a lot sweeter. And I guess, like, if you're projecting the climatic models out, the wine that's actually grown in the UK is going to be quite delicious, which was really surprising. Because usually you just hear doom and gloom, which I guess this is, a proxy for it, but an adjacent thing I never would have considered.
Yes, not far from where I live, actually, there is a local vineyard. And there are some really nice English wines, actually. They're not widely known. I don't think they produce a lot. But we had a green week in the university some years ago to promote sustainable nutrition and all of this, sustainable food supplies, low carbon ways of living, and so on. And as part of this, they had a wine reception at the end with local wines from the region, which I found quite surprising. So some of those were really tasty, actually. There are some good wines.
Yeah, that's what this was saying too, and it made me really want to seek it out. So I might ask you what that vineyard is, just to try it out of my own
Mm.
curiosity. Um, yeah, the shifting, like, climate and what that means for the agriculture and things like that. It's been quite interesting to read into. I'm drinking coffee right now. I don't drink much things. I don't really drink alcohol, but I do love coffee. So seeing how that is shifting too is also quite interesting. Like where I used to live in San Diego, I just moved recently. Um, the water demand on a lot of the crops there is shifting what they're growing. So they're growing a lot less avocados and things like that because the water strain is so much. But if they're actually finding that coffee is taking quite well to that type of climate, which is interesting because I was talking to a farmer who was telling me this, and he was saying that 10 years ago you never would have thought that there'd be a coffee kind of like surging there. It's quite interesting.
Hmm.
I wanted to ask you, as we're kind of poking around, getting started here, what you're working on as far as research these days. I know before, and most typically, it's forests and kind of green cover, but I was just curious to see what your focus has been most recent.
Yeah. More recently, I've started working on a project to do with the monitoring of deforestation-free supply chains. We are involved in a big project now, which is led by the Satellite Applications Catapult in the UK. That is an organization that facilitates innovation with universities and private businesses. And as part of that, we are transferring some of our research methods out of the university into commercial applications that can hopefully help monitor the supply of goods and the imports of goods, and making sure that they come from areas where they don't cause any additional deforestation. So that's an exciting project, and we are working with importers. We are working with companies buying goods that are coming in, and they want to know actually which is the area where they're being produced and how has the forest cover in that area changed in the last couple of years. Is there an effect on the local forest cover from the production?
Wow, that is awesome. And also something that I haven't heard much about. So that is really, really heartwarming, honestly, that they're taking such an active interest in making sure that the goods are being produced in a sustainable manner in some way. That's really awesome. How do you monitor that? Like, how are you tracking that down? Because I'm assuming you're going from like where the base of production is, and then kind of where they're harvesting resources, and using extrapolating from it historicals, and then seeing what that's been like in the more recent. Or I'm poking around. Is
Mhm.
that fair? Or
That's fair to say, yeah. So in the context of the international policy for reducing deforestation, which is called REDD+, REDD, and that stands for Reducing Greenhouse Gas Emissions from Deforestation and Forest Degradation. Under that policy, basically, countries that participate in that scheme have to create what is called a forest reference emission level, and that is the historic amount of deforestation that has happened in the country. And then based on that, one can then compare the current deforestation rates against historic rates and see whether the deforestation is getting less or getting worse. So how this applies to the supply chain monitoring is that usually importers and growers know the areas where they source material from. Let's say we talk about coffee or cocoa or something like this. And they can basically zoom into those areas from space and have a satellite point at that area and create regular maps of the forest cover and where the plantations are to see how they are changing and to see whether the farmers are cutting down some trees to expand their plantation areas. That's in a nutshell how we do it. And incidentally, this morning I was part of a meeting, a virtual meeting, of course, with the Forestry Commission in Ghana, which was held in their offices in Accra. They were launching a national map of forest cover and land cover for Ghana that we helped produce, which contains information on the cocoa plantation extent, where we had done some work as part of a UK Space Agency funded project, which is called Forest 2020. So we have worked together with the Ghana Forestry Commission on that. And the intention in Ghana is very much to use that kind of information for monitoring supply chains and commodities. So they are working on a national certification scheme for deforestation-free exports.
that is awesome. Uh, wow, way to go, Ghana. Uh, what are they? What's the exports? The chief exports in that region or that country?
Well, they are exporting cocoa, a lot of cocoa. They are exporting timber, but also shea butter, you know, the body butter you may know, and a couple of other products, coffee they export, and I think tea. I'm not an expert in the economy of Ghana, I have to say, but cocoa was the commodity we were focusing on in this project particularly, because that was one of the uncertainties in their current data.
That's great.
The thing is,
That's
sometimes with the cocoa plantations, you have lots of small farmers growing cocoa, so there is no central database of some big plantation companies,
right.
but a mosaic of very small farms that are scattered all over the country. And as you can imagine, they can change very rapidly without anyone knowing.
Yeah, definitely. But in this, so this is just an aside. You feel free not to comment on this, but one of the concerns I have with the way that economies are going, and especially under COVID, um, it's further centralization of capital, further growing of larger companies, being kind of the means of what's kind of steadying through this. And then I have a concern of what that if that's going to be a growing trend. So hearing this in such an initiative to, you know, um, I mean, it seems like such a novel solution of we have all these decentralized farmers instead of trying to create some type of centralized network to keep everything in check, actually going from above and monitoring it and then giving certifications at that type of level. Um, Seems like a really awesome novel solution to support that type of small infrastructure, which I mean I don't think this is an ideological statement. Perhaps it is in some level, but I think it's better to keep things decentralized at smaller levels, which I know we talked about before. Like my little shtick of the opposite of globalization is atomization. But this is an awesome example because it keeps wealth in this decentralized manner. It probably stays those individual farmers' livelihoods better, and then being able to certify them seems like a really awesome novel solution that I haven't heard much of things like this. So this is really awesome for me to be aware of this.
Mm-hmm. Yeah, I guess it's a case of watching that space. You know, when the project I'm involved in now produces some results, then there will be more coming out on this front. The name of the project is Forest Mind. So we are trying to create machine learning based methods that can also help identifying any changes early. And we have lined up a couple of companies and stakeholders who are interested in this kind of information. So we're hoping we can serve their information needs from space.
Yeah, that's also a really cool thing to say. Serve their information needs from space. That's
Yeah, there's
awesome.
no other way. Well, there are a few other ways of doing it. And I think you could use airborne remote sensing, of course, but that is very expensive. You have to fly planes ever so often over the area. And, the costs of that actually is much higher than using free satellite data that are provided by the space agencies.
Yeah, that makes sense to me. The only other thing would be like drones or balloons, and all of that would cause, a lot more infrastructure that would be needed. And um, you would probably know this better. You would know this better than I, but I know that one of the big problems in working in Africa is having access to the knowledge economy. So like if yeah, let's just go in and take a bunch of drone footage, or take a bunch of weather balloons that have some type of image data on them, or something, image capabilities. That's all well and good, but it's actually quite hard to do, given sometimes remote areas and getting out there, or even just have access to the knowledge economy, because a lot of people say they would like to go and work, in remote areas, and then they see the pay and they're not going to do it, right? So
that is very much the case. I think universities and companies and so on are quite often concentrated in the capital. In Ghana, Accra is one of the hubs where a lot of things are happening. And there are other universities out in the countryside and in smaller towns and cities. But Accra is clearly a center of the knowledge economy in Ghana. And I've seen the same in other African countries, like in Kenya. Nairobi is one of the buzzing centers of where investment and innovation happens, and companies go there. Your big universities are based there. The best universities in Kenya are based in Nairobi. And all of this is happening there. Partly it's a bit like an effect like in London, where you have government agencies, you have big companies, you have leading research universities, and everything else quite close together. That forms quite a good ecosystem to work together.
yeah, and another analog would be Silicon Valley, right?
Mm-hmm.
And at a certain point, it becomes self-perpetuating, right? Like you have, like in Silicon Valley, like that's a really good case study, because you have all those universities that feed directly into the tech companies. That then the talent kind of either gets attracted to that or centralized in that and stays in there. And then it becomes, in my eye, it comes a little bit turbulent too, because you have all the same people kind of circulating and going throughout everything. So getting new ideas or even breaking the mold of what's there, tends to be a little more difficult. So doing something like this, it's almost like you're taking a dimension higher, quite literally, and getting from
Exactly.
space.
Yeah, and that's why in the University of Leicester this year we are launching a space park. That is a new campus with a big building for about 300 people or so, half of which will be from industry and half of which will be from the university. So we are co-locating all the space research and Earth observation research from the university with some of the leading companies and innovation organizations, some of whom will probably move small groups of people there. Others might have hot desks. So there are different models of engaging with the businesses. But some are renting space and some have more temporary presence. And we're hoping that will create a similar environment there in Leicester, where innovation takes place naturally as part of the daily life, and you don't have to go out to actively seek collaborations because they happen over coffee.
That would be great. Well, once COVID is down and that's up, I'm going to come and drop in at some point. That sounds like a lot of fun.
Yes. However hard it seems to believe at the moment, I think we will get out of it at some point. In the past, pandemics are over at some point. Sometimes after a while, life returns to sort of near normal. But it can take a long time. So yeah, being patient.
Yeah, definitely. I took a couple hours. I don't. I've been moving. I had to like move suddenly from San Diego back to the Midwest, and I've been dealing with that. But so time to me, COVID plus having to move locations, geographically, across several thousand miles, my sense of time is completely off. So it might have been 2 weeks ago, but I'm saying it's 2 months ago. I think it was 2 months ago. But I went back and I looked at the Spanish influenza, and I went back and I actually was looking at some, I think it was Tacitus, some Roman writings of like plagues and things like that have gone out. And my back in the napkin rounding is that a lot of times epidemics last about 18 months before they kind of crescendo and go back down, and eventually kind of go back to normal. So I'm waiting for June. I'm gonna wait till June. I'm gonna just accept life until June and hope that there's a bit of a resolve to it after that point.
Yes, I'm doing the same, and we have the vaccination program here now in full swing. So, all going well, we might get the vaccine by the summer or shortly after the summer. And then eventually, I think things will get a bit more normal.
Yes, I think so too. Uh, the world is changing fast, and it seems like the COVID just sped a lot of the different things up. So I think at least that factor may be a little bit less in the equation, which will be nice. It'll be nice to be able to see people and not have some type of sense of panic.
Yeah.
Yeah. Especially in the UK. I was thinking about you a few months ago when I heard about the new variant. So I'm happy to hear that you're healthy and well, and it definitely seems like it's just everything is coming together at once. So I'm happy that we're still able to talk over the wire.
Yeah. I've been fortunate so far, and I've not had it as far as I know. You never quite know, but I've not had any symptoms, let's say, and I've not been tested because there was no reason for being tested. But then I've been working from home for a long time now, and I have very little contact with other people. So the risk for me is quite low. I know not everybody can stay away from other people as much. Some people have to go to work outside of their own house, and that can be a bit harder to manage the risk, perhaps, if you have to have contact with others.
Right.
We have now moved entirely to online teaching in the university as well. So that's going to stay at least until mid-February, possibly longer. And we all have to make the most of it, So it's an adaptation for the students, it's an adaptation for us academics, but that's the way for now, and we make the most of it.
Yeah, it's a good example of how we're always going to be forced to adapt. So this is just the latest thing to have to overcome.
Which brings us on to computing, because actually I think in terms of Python and programming and all these things, online teaching actually can work really well because you can do so much online. And this is something I do in my master's module now in the coming semester. So we started last week, actually, and my colleague Fernando has been teaching the first couple of weeks. He basically started teaching entirely online in Google Colab, Google Collaboratory, which we're using for all the students to access a similar computing environment. That is a big equalizer in a way, because students quite often have different laptops or different personal computers at home. And one of the challenges of distance learning and online learning is sometimes that you cannot assume anything about the IT that a student has on their desk. So therefore, you have to find a common denominator that all the students can use. And Google Colab is one such environment where you can log on to a virtual machine and you get a virtual desktop on your screen, but you're working on the Google computing infrastructure. And you have a standardized operating system, a Linux operating system, where all the students have the same experience. The computing resource you get depends on the time when you do it and how often you log in and all of this. So there's some complicated algorithm behind it, how it manages that. But overall, it seems to work pretty well so far. And we've been using that successfully for our Python teaching last year.
That's great. One of the things that I've actually noticed when trying to get people into programming is just getting them set up in the right version of Python for what they're trying to do, and understanding like, oh, there's different versions, like there's Python 2, Python 3, 3.3 versus 3.7 mean different things, especially if you're trying to, usually the way to get into Python programming is by using some type of module that then kind of gets you to do something. Like requests is usually the one that I tell everyone to start with, because it's like you can hit an open API and get some data back, and you can kind of start seeing the fundamentals from it. So giving it in that, I've used Google Colab when it was like in beta. I haven't used it in a while. I didn't know they were giving you Linux machines and things like that. So that has to be awesome, not only for easing people into it, because like you said, like not everyone is running the same machine, and kind of getting everyone at a base level. That's really awesome. That's really encouraging to hear that the Google is providing that, let alone that it's going so well.
And it's free at the point of use. So, students can log in for free. It maps onto your Google Drive. So you have some free storage as well to a limited extent. If you exceed that, you can upgrade your storage, but then you have to pay personally. So we try to keep the amount of data we store to a minimum so that students don't have to pay personally for storing data. But on the other hand, if they decided, for example, to become an entrepreneur and set up a company or develop a service out of the satellite data that they are analyzing after graduating, then it's a very small step to go from that free usage of Google Colab to a commercial application where you simply upscale and you say, well, rather than analyzing one small image, I'm going to analyze hundreds of big images and pay the fees for the computing, but charge a customer for the service.
Yeah, that's great. And if you're learning Linux fundamentals from that, you could easily translate that into creating your own Linux box in which you can even just have it run on there, right?
Mm-hmm. Yes, you could, yeah. And the advantage is also that there is some temporary space there. And on Google Colab, you have something like 40 gigabytes or so
that's great.
In terms of free storage space, but that is temporary and that ceases to exist when you log out and the virtual machine closes. So before you do that, you have to download your data onto your Google Drive. But that's not a big step. That can be implemented very easily. What that means is you have some temporary scratch drive, if you like, where you can store data in between for the different processing steps.
Yeah, that's great. It's almost like it's like a big cache that you have for whatever session. It's like session cache, essentially, right?
Yeah.
That's really great. So
there's a good integration also with IPython notebooks. So we use Jupyter notebooks in the teaching, partly because you can annotate them so nicely, because you alternate between a block of code that you can run and a block of explanatory text below. So the students can click on run and that block of text is executed and then you see the output from that. And then you can read the next block of explanatory text that the lecturer can put in, and then the student can move on. So you can break down a complex thing into small steps and explain what is happening in between.
Yeah, that's great. Jupyter Notebooks is awesome. I was going to ask if you were using that. It's really great for exactly what you just described. It's also really good for there's a lot of data. I'll put this in the show notes, but there's a lot of data science, like tutorials and kind of 101s and getting into it that are all in Jupyter Notebooks, and it's quite great. Also, another thing that's hard to get into is setting up and getting Jupyter running on your machine, particularly if you have Macs. For some reason, my development machine is a Linux box that I built, but I personally, for development, I don't think there's any. I'm very biased. I'm not biased on many things, like openly showing how ideological I am, but when it comes to Linux, I'm pretty hardcore with it. Particularly like Pure OS. Are you familiar with Pure OS at all?
I'm not, no.
It's like a security-based one, so it's like very, very hard security locks on it and things like that. It's really, really great. Librem is the company that does it, but everything on Linux when it comes to developing just seems to be so much easier once you get it set up. But Jupyter Notebooks is for some reason very finicky on Macs, so being able to have that in this type of Google environment is awesome to hear.
Yeah. When I started working with Python, I started working on the Windows operating system, but I found that really, really hard.
Yeah.
Just to install packages is sometimes really complicated, and you have to fiddle with the Microsoft libraries and things like this and the registry, which I find really hard.
Yes.
To do yourself, So in the end, I switched to Ubuntu, which is far easier.
Oh yeah, Ubuntu is great. I like Fedora. So if I'm not using Pure OS, I'm using Fedora. I like Fedora a lot. I like the that Red Hat kind of distribution. Plus, I have a much more bend towards open source, just because there tends to be a lot more that you can kind of spin up really quickly. And I like hacking things a lot. So like if I'm and by hacking I mean like doing things there might not necessarily be a library for. So I have to kind of like stitch it together to make it work. Particularly with like physical to digital divide, I'll do a lot of stuff with like Raspberry Pis and Arduinos. And like any Linux-based operating system is going to help you so much more to get to that level. Because once again, like Macs make it a little bit easier because of the terminal kind of being baked in. It makes it a little bit easier than on a PC. But PCs, you have the issue of, well, what version of Windows are you in? Where do you move files around? You have to move a file into a certain directory to get it to work. So I don't blame you for switching to Ubuntu.
No, so what I do normally is I have Oracle Virtual Machine installed on my Windows system. So I start that up and that creates a simulated Ubuntu machine on your Windows box, and then you can work as if you were working on a Linux system, and that seems to work pretty well.
Yeah, that does. Those have gotten so much better over the years. Like
Mm-hmm.
those like virtual machines. When I first worked in another life, when I was in college, I worked like IT server side support. So like for a company, I was like managing their servers and all their machines and all that. And virtual machines then were not what they are now. Like we had virtual machines that were like servers, and that worked quite well. But trying to build little environments like at people's desks of being able to go into like an Ubuntu or anything like that wasn't what it is now. It's so, and even like the VM, is it VM? uh Being able to like port in or create your own local virtual machine that you can then access from
Mm-hmm.
anywhere. Like usually when my home is set up, I'm in between homes at the moment, but usually when my home is set up, I'll have a Linux machine that's actually running connected to my hardwired internet that I can access from my phone, which sounds so novel. But if for things like file storage or things like that aren't in a Google Drive because maybe they're too heavy of a file, or something that's quite outdated, like all of my stuff from college is in there and things like that, it's quite nice. So
Mm-hmm.
learning those little bits of how to's, you can just start extending out in all different types of directions.
Yeah.
So what in your master's course, what are some of the like learnings and modules that you all are working on when it comes to the satellite data?
Yeah, so on the master's course, it's a master's course in satellite data science. Satellite data science is the title of the course. The module I'm teaching on is the satellite data analysis in Python. So this is specifically the Python programming module on the course. Some other modules are working with Earth observation data in general. So we have modules on the atmospheric and ocean monitoring side of Earth observation and on the land monitoring side. We're looking at global data for climate, for example, and we're looking at local mapping for urban areas or land cover and these kind of applications where you need landscape scale data. And some other modules are co-taught by people in informatics. So we have one on machine learning, for example. And it's an interdisciplinary course where physics and informatics, geography, geology, and environment are all getting together to deliver this course. This year is the first time it's really running. My module has been running last year as part of another master's course in geographic information science that we have offered for a long time in Leicester. And so this is the second time I'm delivering this. I'm still learning, so I have to basically adjust my teaching also to the online and remote working environment. And there is a limited student contact, of course. It's harder to work with students online in some ways because I cannot sit next to someone and I cannot actually look at the same screen and point at something with my finger. That seems like a trivial thing, but that is much harder to do if you're in an online classroom and everybody's connected from their home. So that is one thing I need to get sorted, and we will see how that goes. But we want to actually make the most of it. And with this Google Colab environment that we're using, at least the students are all confident they have the same processing environment. So a Jupyter notebook that one student can run will run on the same Colab installation on a different machine, regardless of the operating system or anything else. That's the advantage. That makes it a lot easier.
Oh yeah, definitely. I still, the over the shoulder pointing and kind of, like, oh look, you just missed, you put a comma there, or that's why that code isn't running. That'll be more difficult, but I have faith you'll figure it out. It's almost a good challenge though, right? Because once you're able to break out of this and get it going once, whatever the future is going forward, perhaps the reach of this program can actually be larger than just the physical geography you're in, if you will.
Yes.
So a quick question, and I'm going to kind of keep diving off of this bracket or fractal, as if you will. Why Python? Why are you choosing Python?
Yeah, well, we've chosen Python because on the one hand, we have been talking to a lot of companies and employers, and they told us that they are really looking for Python programmers. So many companies in the space sector, in the geoinformatics industry, anyone dealing with geographic data will tell you that now most people are using Python, or many people are using Python programming. It is integrated, for example, in geographic information system software now. There are GIS software packages, some of the leading packages, both freeware and commercial GIS packages that are using Python interfaces. So with Python, you can actually write your own procedures for those GIS software packages. And partly, I think there is this culture of open innovation. Python programmers tend to share their code, and companies see that as a plus. So there are different ways how companies work, but generally speaking, companies like having lots of different things out in public domain where they can get some inspiration how to do things. And I should say, I am coming at this as someone who is not a trained programmer in strict sense. I have been programming since I went to university a long time ago. At the time I was using C and then C++, and then a bit of Fortran and BASIC and these kind of things. Long forgotten languages, I think, that nobody uses anymore.
You'd be surprised, my clients.
Your clients use them, yes. There is a lot of legacy code out there, so that is one of the challenges. But I also think Python, now many students actually know Python from their school. So we get a lot of students coming to university who have actually had some exposure to Python in school. Certainly my children, when they went to school, were being taught Python, very introductory Python at school. You know, and they were working with the Raspberry Pi, for example, you know, the microcomputer.
UK born.
Yeah, and doing some programming on there when they went to school. So that was an interesting experience. And so we thought, actually, how is Python like? And I used to work a lot in R before. R is more a statistical language than anything else, but it has developed into this data analysis language more generally. However, I found it has some limitations when it comes to memory allocation and working with large images and things like this. So the reason was then we were looking for something else where we could process large data sets more efficiently, and Python came to mind. So there were multiple different strands coming together, if you like. On the one hand, employability of our graduates. On the other hand, the need for processing big data. And Python seemed to be the best solution available right now for all these different purposes.
Yeah, there's a phrase that's eluding me. I'm sorry, I'm a little underslept. But essentially it's the gist of it is, if something works and it continues working, and it's the easiest thing to get working, it's most likely to keep going on and living on, versus something else that might be a little bit better or more efficient or have some kind of novelty to it. You know, essentially, if it's durable, it's going to last longer than if it's like very sleek, which I think is a pretty much Python in a nutshell. It's not the most elegant language. It's not the fastest language, although you can do quite a bit with it to make it quite faster. You know, some of the other like things you get with like C++, for example, where you're able to do like threading and things like that, as far as multiple parallel processing, Python makes it a little bit harder for you to do that. You can still do it though. But really in my experience, the real power of Python is the fact that it is like a true Swiss Army knife, right? Like, not only just because of the fact that it is so stripped down, in the sense of what it gives you, it's more logical to the way that we talk and think as far as how programming goes. So like if you look at C++ or JavaScript would be another great example, which is a quite popular framework that you can use for similar processing of things like Python, but you can also do front end languages with it to make like graphic interfaces and things like that. If you look at Python code and you have no experience coding, you might be able to have some idea of what's going on, especially if you're a more algorithmic minded individual, that you have a sense of that type of if then statements, if you know, logical computing. Where if you look at JavaScript, it's just going to look completely foreign to you. So the barrier to entry is a lot less. And then from there, like, you know, like Raspberry Pi, that's a really great thing. So I'll introduce this. I'm an enormous Raspberry Pi nut. I think I have like 15 or 20 Raspberry Pis. I have quite a few of them. And what they really are, it's a microcomputer. So for anyone who doesn't know that may be listening, what that really means is it's completely stripped down. It looks just like a motherboard. So it just looks like a piece of green plastic with, it's silicon, but plastic with, you know, a bunch of circuits on it. And maybe you'll have some like depending on, if you have the GPIO pins or not. It'll have like pins sticking out of it. And really what it means is it runs a very thin operating system that then you can do whatever on top of. So most people put Linux on it, and most people code with Python in it to do anything from, controlling LED strips to what I have done, which is creating your own micro server in your house that, can store pictures, or, anything from there. I've seen people even make a battery powered, I think it was a Volvo, out of just powering it through Raspberry Pis, which so I got really excited when I saw that. I showed it to a friend, and he's like, "I'll never get in that car." But you can do a lot of really, really, really amazing and powerful things with it. It's also UK born, which, ironically enough, the way are you familiar with how Python got its name?
Broadly, yeah.
Yeah. So the guy who, I can't remember his name, so apologies, who started Python and kind of created the language, was a big Monty Python fan. So he named it Python after Monty Python, which is why if you ever do, anyone who's listening, like a tutorial of Python 101, the first thing you usually do is like spam plus spam equals spam, or things like that, which are quite fun.
Yes.
Um,
Yeah, I grew up with Monty Python on the television, so it's one of the best forms of British comedy. I think there's a lot of great English humor in what they've done.
Yeah, I like. My parents were really into Monty Python, so I used to watch that a lot growing up, and Faulty Towers as well.
Oh yes.
Yeah, I like that one a lot. That's excellent though. So image processing is what you said you're kind of using it for in the modules. So could you explain to me what image processing is, and like an example of what you'd be doing, and then also while along the way, where you're getting the data from?
Yeah, sure. Yeah. So image processing describes basically doing something to an image. Now, an image is just what we see on the screen currently. That's a sequence of images. So the video basically is just a sequence of many images very rapidly, and it looks like the image is moving, but it's not really. It's a series of different images shortly after each other.
Like a flip book.
And a bit like that, yeah. And a television screen has 3 different color channels. It has red, green, and blue channel. But an image from a satellite can have more channels than that. So it can have near infrared, and it can have some non-visible channels, if you like, and mid-infrared and thermal infrared and other channels. Huh. So that is worth knowing, because images are not just the red, green, blue images that we are used to, but they can have some information that the human eye cannot normally see, but that the satellite can measure. And from those, we can, for example, infer the sea surface temperature and things like this, which the human eye cannot see. But of course, you can sense the heat radiation from water, if it's warm or if it's cold, but you cannot see it with your eyes. And that's partly because the human eye only has receptors for red, green, and blue light. That's why we design televisions with red, green, and blue channels. Right. So there's a reason for that, basically to mimic our eyes. So satellites take these images from space, and they come with a number of different bands, spectral bands or channels, sometimes they are called, and we visualize them on screen to see what is going on the ground. Image processing, therefore, describes all the different modifications to those images from the time that the satellite records them to the time that you look at them in the form of a map. So we might be interested in, for example, highlighting particular features in an image. Let's say if we imagine we have an image of an area and there are certain types of land cover. You have an agricultural field, you have a city, you have a forest area and a lake. And we might be interested in highlighting what the lake is like, for example. So what we could do is we could make the lake brighter and we could make the rest of the image darker. That's image processing, and that can be done in Python very effectively. So the first thing we need to do is basically decide what we want to do with the image, and that sometimes is the hardest step. And then we can implement the image processing chain that does all the individual steps of the processing to deliver the map in the form we wanted. Incidentally, that is also how your virtual background behind you is done. So there's some intelligent software behind it that basically sort of looks at you as a person and says, well, this I think is the boundary of the person, and everything else behind it I'm going to screen out with a virtual image.
Yeah, and it's quite funny when it gets things wrong. So I've been moving a lot. Like I'm right now in my mother-in-law's basement. But my wife will sometimes walk in the background. It's quite funny because it'll just pick up her face. So you'll just see a floating head going back and forth behind me occasionally. Um, but that's really great. I actually learned quite a bit right there myself. I didn't realize that I'm a stickler for definitions. And I think it might come from my Socratic past. I've come to realize. But I didn't realize that the image processing includes the different spectral bands. That's really quite fascinating. So you're processing it not just for what's visible to the naked eye, but then processing it as well to then uh, highlight or pull out, and then essentially you're using Python as the translation mechanism to then say, okay, well, color the UV in a certain way that I can see it, color this spectral band or channel in a way that I can see it, which is quite interesting because I've done one of the projects that I have on the table is I want to create like a program that essentially, like, I go hiking a lot. I'm very big into hiking. I want to have it create a map of an area of my hike, but give it in topographic, right? So that it gives the elevation and things like that. Because it gives you a lot more color, and then you tend to remember things a little bit better. I'm using it as a trick to remember hikes a little bit better is what I want to use it for. So you can use Python to then process it to say, okay, now highlight the elevation, and either color the elevation different ways or shade them different ways. But I hadn't realized or even thought of using it to say, well, can you color it for this type of spectral pattern so I can see like the temperature differences, or whatnot. Like in California, I would imagine, where I used to hike out there a lot, in the Cuyamaca State Park, which is a really gorgeous state park. If anyone ever goes out there, I really highly suggest going out there. Just please, whatever you bring, take back out with you because it's a very sensitive habitat. But the Kumeyaay Indians, the native peoples that were there, that was like essentially their like summer villas. Was this area that's now this Cuyamaca State Park. So you see a lot of like geographic remains from them, like stone carvings and things like that. It's quite fun to find. But one of the cool things there is if you hit certain valleys, the temperature will drop like 15 degrees by pretty much just walking through almost like a curtain. It feels like, right? So like that's something that I've done as like a quick thing of like thermal. Like, can you give me like the temperatures on there? But that I didn't realize you could use to the level of these different spectral channels, which is quite interesting.
Yeah, you can do, for example, a combination of different spectral wavelengths.
Huh.
So for vegetation monitoring, that is quite often done to identify areas where the chlorophyll content in the vegetation is high, so where the plants are green. The plants are green because of little chloroplasts in the leaves that are little sort of green encapsulated things where the photosynthesis happens and plants take up carbon from the atmosphere to store that in the woody material and leaves. And the way this can be done is by using the red and the near infrared bands and combining them to a vegetation index. So you take two spectral bands and combine them to one band, and that one composite band, if you like, is the index that indicates basically where the vegetation is greener. That is one way of doing it, and that is a common application in vegetation monitoring, because that allows you to see where the vegetation is vigorous and where the vegetation is suffering from drought, for example, where it is prone to fire, all these kind of things.
Wow, that's really interesting. So you're taking two inputs and then you're creating one output from it. That's essentially, so you're like you're taking those and you're regressing them into one stream, which then you can say extrapolate on like a high low ranking of wherever it is to say this is high vegetation, and it's very healthy or green, or lower vegetation and are starting to suffer from drought. And I'm assuming, because I'm always going like 10 steps ahead as far as machine learning, this is something that you can then have go over and over and over and over again and understand if this area is trending a certain way, or not, and then having a computer script, which is something else you can do with Python. Computers never sleep so long as you don't pull the plug. So if you have this running all the time, you can actually have it bump up to you and say, hey, it looks like this area on the map over here is starting to trend into a drought. Why don't you come and take a better look? Is that fair?
That's fair to say, yes. And actually, the United Nations and various other organizations are already using systems like that for drought monitoring and for early warning systems for famine.
Huh.
So in East Africa, there is a system that works exactly like this. It's based on a continuous stream of images, and based on the red and the near infrared bands of the satellite image, the vegetation greenness is worked out, and then the software then creates maps how green the vegetation is at this moment in time in comparison to an average over the last 10 years. And then if the vegetation is a lot less green than you would normally expect at this time of year, then it gives a warning and says, watch out for this because it might indicate a crop failure.
Huh. That's fascinating. Way to go, United Nations. That's a smart novel application right there. Um, wow, that's really awesome. Um,
There are even some automated systems where farmers can opt into crop insurance in Kenya. And those farmers that participate in that scheme can get automated payouts depending on the satellite images, indicating that the crops are not doing so well.
huh.
So there is no need for sending out a field inspector because the travel can cost a lot. The distances are far and the infrastructure is sometimes difficult. But it means actually that the satellite looks at one particular field and says, this year the vegetation is not so green. The farmer has not been lucky, the crop is failing, and that then triggers a payout. It's all
That,
done electronically.
that's awesome. That's really great. I haven't been studying Africa in the past 5 years as much as I did before. Mostly just because China is concerning me, but that's for another topic. So I know in just to kind of give a frame of reference for anyone that's listening, if you live in the States, uh, we really take for granted our interstate system. So like how much there is roads. Like I just drove from California to just south of Lake Michigan and Indiana, and I was able to do that without any problems. The weather was a little slick at times, but I got all-wheel drive, so it was fine because it's on concrete roads. But something that is a huge issue in Africa is roads and having access to roads. And something else that I think, at least speaking from an American perspective, that we take for granted is how much we don't feel the elevation when we go on those roads because they were so smartly built. Like for example, I think it's like the Eisenhower Tunnel in between Grand Junction, Colorado, and Vail. It's like one of the highest and longest tunnels in the world. Um, like you don't feel the elevation, you don't feel like you're going through a mountain, but you are. And even the steepest grades on any of these interstate roads isn't that steep because they've smartly mapped out where to go in the valleys and how to take out roads, how to take out mountain and earth with dynamite to do these things. And that is an incredibly hard thing that we had to do. But we had the luck, if you will, that we don't have jungle in much of America, right? And we do have mountains, but the ranges are actually quite thin in comparison to where they are other parts of the world, right? The Rockies is the thickest, I would say, like the most east-west as far as our mountain ranges. But if you get into sub-Sahara Africa or East Africa, we're talking quite quite distinct foothills and mountains that make getting around quite difficult. And most of the roads are dirt, and if they are dirt, you can't expect them to be maintenance. And monsoons is a season. You have a monsoon season, so you have to worry about what's going to happen when it rains, and then roads are actually quite dangerous when it rains because that just means it's an easy avenue for water to flow. So what I'm trying to say is that in Africa, you have so much more to contend with when it comes to all these different various means. Being able to just go to the sky and come from above because of what I said before. You have the knowledge economy you have to worry about, but then also physically, how are you going to get people there? And you can take a brush plane, maybe, but the weather in Africa is quite tenuous at times. So anyone who's a fan of Hemingway would know getting around in a plane hasn't really changed very much since when he went around. So
Mhm.
that's really quite awesome that that's happening, especially with like the kind of skipping of landline infrastructure that Africa is getting, and they're going straight to mobile. So that's very great. Once again, the decentralization, I think that's amazing. Um, so to the data, the going back to that, where are you getting these images from? Is it free? Are you paying for it, or because of some relationship you have? Are you getting it, and how is that going?
Yes, so we get most of our data now from the European Space Agency, from the Copernicus satellite missions. There's a series of satellites called the Sentinel missions, and they are currently, there are 6 missions or so. Each mission has several satellites in orbit, and they are acquiring regular images. So the commitment is there to continue those observations in the long term. So they are not one-off satellite missions, and when the satellite dies, there is no more data. And that means actually, as a user organization, I can have confidence that this data set is still going to be around in 10 years' time. That in the past has been a big barrier to the uptake of satellite data in organizations, because you're not going to change how you monitor the performance of crops if you're not confident you can get the same data next year.
Yeah.
So that's why we're using Copernicus data a lot, because there is this long-term commitment to continue the satellite data supply. But we are also working with commercial missions, commercial satellite data. So we have done some work on the Planet constellation. You may be familiar with that. That's a US company, I think, multinational company now. And one of my PhD graduates actually works for that company now in the UK. The Planet constellation is based on the idea of making a satellite as small as possible and mounting a very cheap mobile phone camera on it. To keep the launch costs down. They actually pack them into a space shuttle that supplies the International Space Station. And that supply shuttle, when it docks, basically opens the airlock and throws out the satellites into orbit. So you don't have to fire up a big rocket specifically for the satellite launch. That is the biggest cost quite often for launching a new satellite mission.
Yeah, certainly. The amount of money that you pay per pound to get to something into space is quite jarring. I think SpaceX has gotten it down quite a bit, but it still might be in the 100,000 range per pound or something like that. Just to give a ballpark, I don't know exactly, but it is quite expensive. So is this data? If I'm walking off the street, can I get access to these images?
You can get access to a lot of imagery for free now. So yeah, the Copernicus satellite data are available to anyone. So you can access those from the European Space Agency directly. You need a bit of technical knowledge to do that, I think. But there are some interfaces where you can go to a web browser and you can just search for a range of images for an area, and it just shows you a map. So you don't have to necessarily download everything and process it yourself. However, that's what we do, and we teach our students how to do that. It's a bit more advanced, but that is probably also where a lot of innovation takes place. But yeah, anybody can get to those data. You can find the Copernicus mission online, if you search for the various satellite missions. I personally think the Sentinel-2 is a good way to start. And Sentinel-2, I'm saying that because it has a 10-meter pixel resolution. So you can see things that are at least 10 by 10 meters in size. That's 1 square in the image, if you like. And that means it's quite close to what we would see from an aerial photograph. Not quite, but almost. It sees individual details of road infrastructures and things like this, and houses. So it's better than Landsat, which is one of the satellite missions that has been around for a long time and has a 30-meter resolution, and provides the longest consistent record of data. But the Sentinel-2 mission picks up smaller types of changes.
Yeah, 10 by 10 meters. That's spy level almost.
Yeah, and generally I think that is the boundary currently, where 10 by 10 meters data you can get for free. Anything with a finer resolution than that is probably commercial data. Having said that, actually, with the Planet data, for example, as a researcher, you can apply for free data. And with the research license, you get a limited access to a set of sample images that you can select. And you can start working with Planet data. Many commercial providers actually have similar schemes in place, so it is always worth having a look. And those tend to be higher resolution, but sometimes not quite as detailed in terms of the number of spectral bands, which I mentioned in the beginning. So the Planet tends to have fewer spectral bands than Sentinel-2, but that's simply because they went for the cheapest camera technology they could find. And Sentinel-2, because it's publicly financed, went for a very sophisticated imaging system that is actually able to see things like the status of vegetation health. And it has a lot of different spectral bands that are specifically made for parts of the spectrum that respond to vegetation condition.
Wow. That's
So
really
that's
cool.
perhaps also an interesting feature of that. This in the science community, we call that the red edge position. And that is where in the wavelength spectrum, the red light changes over to the near infrared. And there's a steep increase in the reflectance because the red light is absorbed by the plants and the near infrared light isn't. So it's being reflected away. And the position of that red edge, where the reflectance goes up a lot, indicates something about vegetation health, depending on whether it's quite close or not so close to the red.
So is that how you do that with the spectral analysis on those two to regress it? Is you see how much of red is being absorbed by the plants versus how much is being reflected off of the infrared?
Yes, we would do that this way. I'm just going to have to plug in my power cable. I think otherwise I'm running out of juice in a moment.
No
Talking
worries.
about technology, what can possibly go wrong?
Yeah, everything.
Yeah. Yes. So where was I?
Oh, the reflecting of infrared versus absorbing of the red.
With the red edge position. Yeah. Yes. Thank you. So with the red edge position, that can actually allow you to see which plant species is there in which place. So you can make maps of the locations of different species. Because they have different leaf biochemistry going on. The photosynthesis is functioning slightly differently, and the leaf chemistry means that the reflectance is slightly different. And depending on the leaf chemistry, the position of the red edge can be shifted a little bit.
Huh. That's fascinating. So you could actually figure out like if, okay, I'm just going to throw out some species here. If like a type of fern is growing more than maybe a native species of grass or something like that, you can be able to figure that out.
Should be, yes. Some plant species we can discriminate, but some others we can't. So it depends partly what you're trying to map.
Right.
I think it's probably not at the level of mapping every single species, but mapping groups of species that have a similar leaf chemistry.
Right, that makes sense. So, I just recently saw this once again, time is eluding me. I think it was a few weeks ago, but who knows anymore. Where the French President Macron was talking about the desertification of the Sahara and the Great Green Wall that they're trying to build. So this would be an example of where they'd be able to figure that out. Not only just because of desertification of saying like, oh, there's getting more sand here, but particularly that maybe species are getting forced out because of other species, which then makes the environment more turbulent and more likely to be, become a desert.
Yes, that's the kind of thing you could monitor with the space satellite technology that I mentioned, where you could produce time series from the various vegetation indices that I mentioned. So much like we are in a video, that is a series of different individual images, you can produce videos from different satellite images in the same sort of fashion. So one thing we do, and I teach this in my master's module, is actually we are monitoring an area by creating a map of how green the vegetation is at one time, making another map with the next image we can find, and then we stack the images into like a pancake stack of different images, and then we play a movie through that stack and we see how the greenness is changing over time.
That's really quite cool. So I'm asking this as a bit of a selfish, but it's actually a bigger part of the population. So I'm red and green colorblind. So would you be able to, even in this type of spectral or image analysis, be able to flip the colors to maybe making vegetation green to making it yellow?
That's very easy to do, actually, yes. And so it's actually a good point, because for colorblind people, you have to think about how you can visualize the change you're interested in. And a common mistake that many people make, and that I have made in the past, is that people tend to visualize forests as green and change as red. But of course, as a colorblind person, that basically doesn't show you anything. So therefore, I think it's good practice, for example, to think about something bright like a yellow to indicate change. And there is some guidance available what the best color schemes are for visualizing images. That's another advantage of image processing, because you can make the map such that it highlights the features you want to show, and taking into account the visual conditions like color blindness and possibly some other ones, to make them as usable as possible.
Totally. Yeah, that's great. It's always surprises me how big of the male population worldwide is actually colorblind or color deficient. I'm very damn near colorblind, like red and green almost don't exist to me. But there's other people that I've met, numerous people who, maybe have just a little hint of it. So trying to always give more of a wider breadth to get people into it. Okay, so what Python modules do you use? Are they open source? And do you use a series of them to kind of chain them together?
Yeah, so we use a number of different modules depending on the application that we use. So I'm using Raster.io, for example, for working with raster stacks. That is quite good for just working with spatial data. Um, but I'm also a fan of GeoPandas. GeoPandas is a development based on the Pandas library, but it's made so you can include geographic map projections, which means you can, for example, reproject an image from the projection it comes in to another local or national map projection. So you can imagine if you take a map of the world, there are different ways how you can visualize how the Earth looks like. Because we are living on an ellipsoid, we cannot visualize that as a flat map very easily, but we have to do that somehow. That's what map projections basically do. They help you basically squeeze down that ellipsoid onto a flat surface. There are a number of different ways how that can be done. And GeoPandas, for example, allows you to do this in different ways. And it allows you to have information on which projection or which map type the image is in to be added to the data. So it's great for those purposes. It also makes it very easy to work with line data or vector data in addition to the raster data or image data. So we can overlay, for example, where our areas of interest are, let's say the cities or the forests or the lakes we're working with. And we can also use it for extracting statistics very easily from the images. So we could look at actually not just how green the vegetation is visually on screen, but we could also extract numbers, how green it is. So getting numbers out of data is always in research, of course, is incredibly important. And Python is great for this kind of thing. So
Yeah.
Raster.io, GeoPandas are really good ones. Raster.io is based on the GDAL library. GDAL provides a wide range of different map projection information techniques, and it also allows you to reproject your maps directly and to change the pixel resolution of an image and these kind of things. And I should say that I tend to work in GeoTIFF format. That's perhaps another thing worth saying. GeoTIFF is a very widely used image format, and it makes it really easy to import the data into any analysis software that students might be using. Any GIS software can use that, and you can visualize it very easily on any computer. So one of the things you should probably know is satellite data sometimes come in the weirdest data formats, because for each satellite mission, the space agency puts a team of experts together who scratch their heads and think about how do I compress this data most efficiently? And they come up with the most wonderful and weird systems of compressing the data that make it really, really hard for someone who is not a trained computer scientist to access them. So GeoTIFFs are great, partly because that's similar to what we know from photographs, digital photographs, very easy to convert, anything can read it, and easy to visualize.
That's great. And a TIFF format, correct me if I'm wrong, that's essentially it's similar to an SVG in the sense that it's taking an image and it's not compressing it into pixel like a pixel render. It's actually putting it into essentially a numerical form so that it's easier for a computer to process and then recompile or manipulate and kind of change the string in some manner to. That's why it's so easy to make something red to yellow or something like that. Am I correct in that?
Yeah, it has a compression technique, so it can actually reduce the size of the image depending on how much information is in the image. If it's very complex, it cannot be compressed very much. But let's say if part of the image is just black and there's no information there, then that part is compressed. So the software is clever enough to say the left side of this image is completely without any data. So I don't need to spend lots of memory space storing all the zeros. Let's just say anything beyond that line is just not there. And that's a great feature. It also means you can store different visual bands, different spectral bands in the same file. And I'm a great fan of actually having everything in one file if possible, because otherwise you end up with a complicated file management system. But interestingly, GeoTIFFs are quite clever because they can store more than just the 3 red, green, and blue channels. So you can have more than that in the same TIFF file. And that is also very good for image analysis on a scientific level.
Yeah, or going back over something and looking for more information, because you can store it in that manner, and then 10 months or 10 years later you can come back and say, I want to see what the trend's like, and it's all stored there in one place. Which, if anyone is going to take this episode and start coding, be very cautious of your way you store your files and where you store everything, and create very smart nomenclature. Maybe I'll even make a blog post when I post this of how I do it, because it's been a lot of trial and error to make sure I don't lose wherever something is, because that becomes, especially when you're programming and you're building scripts to execute things programmatically, doing things smartly, such as numerical formats or dot formats and things like that, help create a way in which the system is able to go over the images, or even find it a lot faster, which is great.
Mm-hmm.
Is it Russell.io? Is that what you were saying?
Raster.io. It's called
Raster.io. Okay.
Raster.io.
Okay. Raster.io.
IO stands for input output. So it's a simple package that allows you to read in raster data that are like an image format, and you can work with the different layers very easily. So it just has all the basics. It's a bit like a toolbox that has all the basic processing steps. And then based on that, you can then expand a little bit and use GeoPandas and things like this, which are more sophisticated. A good package is also scikit-learn, just the machine learning package, which is part of the scikit library. Scikit-learn actually is really good at classifying images with a random forest classifier, which is one of the machine learning methods. It has a number of other machine learning algorithms, and you can tell the software basically what types of land cover you see in your image. And then based on those areas that are of a different land cover, it can then classify the whole map.
That's really cool. So you could build your own map of where you live and have it classify different regions as coastal or forest or water, or desert or anything like that.
Yes,
Farmland,
that kind of application. So this is one of the exercises I'll be doing with my students in a couple of weeks' time. So if you're watching, watch this carefully. It sounds more complex than it is, but a random forest classification basically just tries to find for each part of the image what is the most likely land cover in that part of the image based on what I see in the different image bands or the different colors, if you like.
That's great. That's really cool. So you'd be able to, and then that goes for, is this spatial data from both the Sentinel and Sentinel-2 and from Copernicus, are these global, or are they more of just like regionally focused, like like we were saying, Africa, or maybe even like a longitude, or is it just trying to map the whole of the marble, if you will?
Yeah, they are available for the global land surface.
Huh.
The Sentinel-2 data are. Some of the Sentinel missions are available globally, so they're also ocean missions, and they take images very frequently as well. So with the Sentinel-2 data that give you a 10 by 10 meter spatial resolution with a lot of spatial detail, there's an image taken every 5 days over every location on the planet.
Oh, wow.
So you can see on a weekly basis how something is changing, provided there is no cloud in between. That's the caveat. So if you're living in a very cloud-covered area, you won't get many cloud-free images, unfortunately.
Yeah.
If you do live in a cloud-covered area, then I would say choose a SAR satellite. SAR stands for synthetic aperture radar. And this is basically a radar instrument in space that sends out microwave radiation that can go through the clouds, and it gives you an image even under cloudy conditions. But it doesn't look like a photograph, it's a microwave instrument.
Yeah, so it looks a little grainy. Is that a good way of putting it?
Yeah, it does. Yes.
Yeah.
It looks a bit like salt and pepper, it has been described sometimes. Yeah. But you can do a lot with image processing to actually make it look nicer. Like you can do a temporal filtering where you just stack a lot of different radar images on top of each other to reduce the noise. So you make one image out of 10. And by doing that, by averaging, you are reducing that salt and pepper appearance, and it looks almost like a photograph sometimes.
Oh, and I would imagine that's just going to get better with time. Both the processing of it with ML algos, as well as the actual like raw taking of it, as the type of technologies probably progress. That's really awesome. Thank you for such an overview. Is there any? I want to ask you a couple fun questions while I have you for a few more
Go
minutes.
ahead, yeah.
Yeah, is there anything else with this that you'd like to give as kind of a primer? Because just to kind of get the audience, I'm going to try to get this out there as a way of giving people an introduction into Python computing, as well as doing this type of work, because I think it's a very fun way to get people into it, and especially like in the type of work that I do in consulting, I can tell you right now, you can learn how to do this type of geographic mapping, and if you would like to do that, that's great. But as far as learning the basics of Python and computing, you can definitely take this to build a career in any number of image processing fields with Python, which is quite great. So anything else
Yeah.
before that, before I start asking you some fun questions?
Yeah, I guess what I find Python is great at doing is automating the processing of satellite data. So if
Mm,
you want to do something automatically, Python is the software of choice. If you have a menu-driven software, you have to click your way through so many different levels, and you have to do it again and again for every new image you get in. With Python, you do it once, and then you just plug the next image in and click on run, and everything is happening like you want it to. So it's great for that. I'm personally a problem-based programmer, so I'm maybe not writing the most stylish software, and I think computer scientists would probably tear their hair out when they look at my code, but it sort of works and it does the job I want to. And for that reason, actually, Python is great for going in little steps. So you break down a big problem into small problems, you solve one at a time, and then you link them all together into a function, and then you call that function, and it does everything in one. So that's how I work, working in little steps, solving a small problem, fitting it into the bigger processing chain to solve a bigger problem. And then once you've got that, then you can run everything again and again very efficiently.
yeah, that's great. That's great advice to give too. So don't break things down into small steps. Don't get frustrated. Don't try to be the best programmer right off the bat, because even you're being self-deprecating, but it won you a Copernicus award. So it doesn't have to be the most beautiful.
Well, I mean, we shouldn't be ashamed to say that, we might not write the most elegant code, but if it works, I think it's fair to say also, don't put yourself down if something doesn't work, because programming comes with a lot of disappointment and a lot of frustration and a lot of shouting at the screen, I think is my experience. Yes. So don't think you're a bad programmer if that happens. That's part of programming, but you will get better over time. So yeah, I think making small steps, starting with a hello world or something, spam equals spam, is not a bad way of starting.
No, and I think I'm gonna just bracket off that for 1 second. Like, the biggest advice I'd give anybody starting into programming is accept the fact that no matter what level of programmer you are, you're always gonna run into a part where you want to bash your head up against the wall and you have no fucking idea where to go from here. But the best thing to do is just try to accept that and move on to an adjacent thing that you're trying to do, and then come back to it when the time comes. Don't just continue spinning on whatever that is, unless you're at some type of time crunch, because that'll happen where you have to just fix it. I've launched several things and been like, oh my God, how did that break? I have no idea. I have to stop right now and fix it. But those type of something happened, you don't know what to do next, just move on to something else and come back to it. That's actually the natural course of any project, is getting to a point where you have no idea what to do, or even what broke, so that just happens. So fun question. What is your favorite part of the earth to look at, aesthetically or other?
Aesthetically or other? My favorite part of the world to look at, I think, is probably the Caribbean. The reason for that is that it's one of the most colorful parts of the world. When you look at satellite images, there are so many different landforms and forms of the islands, the different ocean colors, the different waveforms, the different clouds sometimes that you see. And I find looking at the Caribbean is never a disappointment.
I like that. Maybe that if anyone wants to take it on as a project of taking your kind of run through of how to take satellite images, maybe starting there for aesthetic reasons, that would be quite pretty. It's also, if anyone else wants to start, I've done this before actually, is I've taken satellite images and created a mosaic composite of a few of them, and then you can make it as a quite nice print in your house or something like that. So the Caribbean, that's awesome. What about weather patterns? What area of the earth do you like watching as far as weather patterns?
As far as weather patterns are concerned, I'm quite a fan of South Africa, partly because I have been in bad weather in South Africa and it's absolutely amazing. If you get into a thunderstorm in South Africa, it's nothing like the things we have here in the UK. It's absolutely monstrous. When I was there, actually, it almost flooded the entire Kruger National Park. When these rain systems come in, it's just like a black wall of clouds moving in, and then it starts raining until the water rises by 10 meters or more, and the rivers overflow and dams are being washed away, the roads are being washed away. So I watch those weather systems with great respect from my screen, having been in one.
That's great. How long will these storms last that are raising dams?
They don't last very long. That's the thing.
Huh.
They are very short and sharp storms quite often. So they sweep over the area and all the rain comes down in a very short space of time. That's why they're quite so destructive.
I can imagine. Is that because of they're coming out of the mountains, so they're quite energetic and
no,
wet?
they're coming from the Indian Ocean, actually.
Oh,
so
okay.
in the Indian Ocean, there's a lot of heat building up and a lot of water vapor going into the atmosphere from the Indian Ocean, and that can be transported over Mozambique into South Africa, where it then rains down. That's where it comes from. That's why these storms have a lot of energy and have a lot of water.
And probably why they all break at once, because it's all just moving. I would imagine the jet streams are making it move quite fast. So once you just kind of pop the balloon, it just all comes out.
I don't know quite why they move like that, but I think it's probably partly influenced by the El Nino, although that is not the traditional El Nino area. We think of the Pacific mainly, but the Indian monsoon, I think, is sort of connected a little bit with the El Nino system via telecoupling. There are probably other oscillations going on in the climate system that influence that. Yeah, but it's one of the most impressive things you can see. If you're in South Africa and it doesn't rain for weeks and weeks and weeks, and then you get a weather front like this coming in, you think, where on earth am I? What's happening?
Yeah, like otherworldly almost, right?
A bit, yeah.
I lived in Taiwan for a little while when I was in school, and when the typhoon season happened, like that was not anything like I come from the Midwest and we have tornadoes. I've experienced tornadoes several times and I've experienced like really crazy thunderstorms, and lightning strikes that like one of the times a lightning hit when I was living at a farm, hit a tree not that far and seeing it split and just that was nuts. But I never experienced just a sheet of water where it literally looks like I would open my back balcony up the door and it would literally look like a sheet of water was there. And like I have never until that point experienced what it's like to have your visibility cut so much. Like I probably couldn't see further than a few hundred meters in front of me because the water was just so dense that it just disappeared the rest of Taipei, which was quite wild to experience. So to see that, but to see the water even being more than that, is got to be some sights. I'm gonna take a look at that some spatial data from there and see what those storm systems are like.
Yeah, have a look. There are some maps out there on flooding in Mozambique, I think, that you can look at.
I'm gonna do that. What about your favorite mountainous region?
Oh, favorite mountain region. Well, the mountain region I know best probably are the Alps in Europe. So that's one of my favorite areas. It's great for hiking. It's great for day trips as well as longer trips if you wanted to. I've not done a longer trek, I have to say, but it's a fantastic area. It's absolutely wonderful, and it's very easy in terms of tourist infrastructure. So if you like touristy kind of holiday and you like your bed and breakfast, you like your restaurants nearby, that's a good area to go.
That's great. That's great. So you have a before life before you started looking at satellites and mapping the Earth from above, and now you have this second half of your life in which you are looking at satellites and all of that. Has your perspective on life and the Earth changed at all since doing that?
It probably has. That's a very good question, a very deep question, actually. In my PhD a long time ago, I was actually studying agricultural and environmental sciences back in Gießen in Germany, long time ago. And as part of my research then, I was looking at determining the different types of grass that grow in a meadow. So I had my plant book with all the Latin plant names, and I was sort of counting which plants I find in that meadow. on a regular basis. So that was quite a tightly confined sort of project. Then I got into statistical modeling, but it was all very local. I think having studied global phenomena like climate change and looking at global maps and these kind of things has changed my outlook on the planet a little bit. Partly also because I think now the effects of climate change are so strong that more and more people feel them in their local environments. Whereas a long time ago, I think it was more like a theoretical debate for most people that nobody could really relate to. I think the outlook on life has definitely changed from that. And looking at satellite images can change your perspective. Some of the early astronauts were saying that, that they sort of felt like their life is changing. Having seen the Earth from the moon or something like this changes your life forever. And I think it's about perspective, isn't it? You realize actually that you are a small part in a big universe somehow. And actually, one thing I really love about my job is that the Earth is a beautiful planet. When you look at it from above, it's just amazing what you find. So, I could spend hours and hours just looking at Google Maps and scanning around the Earth and finding interesting places and seeing what's there.
Yeah, I have a lot of fun doing that as well. I have also a quite kind of like how I said earlier, I like studying economics because I feel like not only do I find interest in it, it also seems like a bit of a shortcut or a hack to learn more. I recently have done the same with fractal geometry, and understanding like the Mandelbrot sets is what kind of blew me into that. And now I've been looking at all different types of fractal geometry. But I was in San Diego, and I was there's this area called Sunset Cliffs. It's quite gorgeous. These sandstone erosions. And I was looking at all the different ways in which the water and wind created these little fractal patterns on there. And then my wife bought me as a gift, because she knows how much I like satellite imagery, this book called The Earth from Above, which was this BBC publication.
Mhm.
And it was really quite amazing to see how, when you look at a beach and you see, like in what I was just saying, you see these erosion patterns that look like little lightning bolts almost. If you haven't seen it, like that's what a fractal pattern is. A lightning bolt is an example of it. And then you start seeing the Colorado Rockies from above, or you start seeing like different foothills. You see the same patterns emerge, and in much the same way that you realize, at least in my eyes, the way that I realized that the Earth is just a small part of this greater universe or this greater cosmos. What you see in a beach is just a greater, smaller subset of what you can see in all of the Earth, and the beauty therein is quite astounding. And yeah, I appreciate you answering my question, especially one that was quite deep and a little targeted.
That's fine. Yeah, no, you're welcome.
Well, thank you for your time. I'll pause it, pause the recording in a second. Anything you want to add, and then we can wrap?
No, thanks for your time. I really enjoyed our talk.
Me too. Thank you. If you'd like to know about episode drops, check out our episode catalog, find ways to get us on different streaming platforms, or leave us a comment. Please reach out to us at bandwidthpodcast.com.